Hello, welcome back. Today we're going to continue with our lesson from last week. So let's get to it. So 19. I want to factory design a picnic table as shown below. If the table top is parallel to the ground, okay, this part is parallel to the ground, just this, approximately. Yep. What is the measure of the angle of the table legs made with the ground? And put your answer in the box. So this actually, there are a lot of ways to do it. But if I'm not mistaken, you guys must know the consecutive angle theorem. So I have this approximately the leg. I'm trying to draw it, but So I have this, which is approximately the leg. And we know this angle is 112. Now, this angle, which is making a C, as I explained in other videos, is the consecutive angle, and consecutive angles add up to 100 degrees. I can say this x. So 112 plus x equal 180. 180 minus 112 is just x equals 68. So this angle is equal 68. Now this is a table. If it is parallel to the ground, it means that this angle must be equal to this one. So this angle will be also equal to 68. So 68 as well. Also this angle will be 112 as well. Since it is a table, so if it's not the same or this angle is greater or smaller, the things like the obvious will either fall to this side if this angle is greater, or to this side if this angle is smaller than this one. So yeah, that's basically the reason behind that. Now 20. So you want to build a plant stand with three equally spaced circular shelves. Okay, you want the top shelf to have a diameter of 6 inches and the bottom shelf to have a diameter of 15 inches. The diagram below shows a vertical cross section of the plant stand. What is the diameter of the middle shelf? Enter your answer in the box. So as you can see here, this side is equal to this side is equal to this side. So I'm looking right now at a mixed segment of a trapezoid. So if you know the mixed segment of a trapezoid will be equal to mixed segment is equal to base 1 plus base 2 over 2. Now I have the two bases, so I can say m equal 6 plus, okay, I'm gonna do it in the side, m equal 6 plus 15 over 2, which is equal 21 over 2, which is going to be equal 11.5. Oh, sorry, 10.5. So this is the answer, 10.5 inches, or just 10.5. Yeah. Now, a staircase handrail is made from congruent parallelograms, as shown in the figure. Okay, these are congruent parallelograms. Nice. In parallelogram team, TE equal, whatever. Okay, they say all that. So what I'm gonna do is label it. I know the TE is for x minus 2.5. So I have TE. I have for x minus 2.5. Then I have MA right here, which is 6x minus 14.5. 6.4x. 24x minus 14.5. Then I have MW, so MW, and MW is 18. And I have angle DEA, which is this whole angle, and this angle is 110. Now, find each measure. So I want to find MA. So remember a key feature about the parallelograms is that the opposite sides are equal on parallel, but they are equal. So this side must be equal to this side. Okay, let me use another color because that one is not very visible. So yeah, since they're equal, I can say that 6 here. 6.4x minus 14.5 is equal for x minus 2.5. Now I should start from x, for x from both sides, and add 15.5. This is minus. So this cancels out here, this cancels out here. 6.4 minus 4 is just 2.4x equal 12. 14.5 minus 2.5 is 12. Now we divide both sides by 2.4. So x equal. Okay, I went to the calculator and somehow close the recording. So what I was saying is that now is 12 divided by 2.4, which is 5. So x equals 5. Now they're asking for the measure of MA. So, um, you know, 6.4 times 5 minus 14.5. 6.4 times 5 is 32. So 32 minus 14.5, which is 6, 17.5. Wait, 17.5. Yeah, 17.5. So this is the answer. 17.5. Now, we want ME. And this is another property of the parallelogram. You know, the diagonals are going to be um bisecting each other. So this side of the diagonal is equal to this side of the diagonal. No, the same diagonal divides in two. And then let me use. Okay. Then this side right here is equal to this one here. No, this divides in two, then this divides in two. This one is not equal to this one. That's not happening. So since we know that, now I can say that this side is 18 and this side also needs to be 18 since these two are equal. So I can say 18 plus 18 and that's going to be 36. So that's our answer. Now for angle MTE, so MTE is going to be this angle. Let me use, like, I'm trying to use different colors to wait. Not working the way. So it's this angle right here. Now these two angles are supplementary. So the adjacent angles of a parallelogram they add up to 180 degrees. So if they add up to 180 degrees, I'm just going to say this angle T. So T plus 110 equals 180. So T equals, which are 110 from both sides. So T equals 70. So this angle equals 70 degrees. And now angle TMA, as I said before, opposite angles, what is opposite side, opposite angles, diagonals to each other, they are equal. So it must be equal to angle E. So this will be equal to 110. And that's all for this exercise. So let's keep going. 22. A railroad bridge has high sections that show isosceles trapezoid. The trapezoid ABCD represents one of these sections. Okay, isosceles trapezoid before anything. I'm going to establish this angle equal to this angle. So the base angles are equal. And then this angle equal to this angle. And they already said the sides are equal. So we are fine with that. Now, we also know that AC, the whole diagonal, is equal 13.2m and BE which is this part. Oops, is 8.4. And we want to know the E. Okay, this is actually an easy exercise if you know the properties. And you actually didn't need to know the angles for this one, but either way, in an isosceles trapezoid, only a isosceles trapezoid, the diagonals are equal. So if the diagonals are equal, um we can say that dv, this whole thing, is also equal to 13.2. Okay, let me show you. So this whole thing is equal to 13.2, and we know this side, and we want to know this side that we don't know, so we can just say 13.2 minus 8.4. So to know this side, and that's going to be 4.8. Let me make sure. 13.2 minus 8.4. Yep, 4.8 equal 4.8. And yeah, that's our answer. Simply. Let's keep going. So 23. Quadrilateral best has diagonals that intersect at point D, which statement will not be sufficient to prove quadrilateral best is a parallelogram. So let's draw this. A basic parallelogram. Let me use another color actually. Actually black. Okay. Oops. Oops. Trying to do my best diagonals. More or less, this is what it should look like. Yeah, more or less. Okay. And this is point D. Each time it would not be sufficient to prove that it's a parallelogram. So let's see this. BDE, BD, oh wait, B, best. So B, E, S, D, best. And we know that BD, congruent to SD, and then KD, D, congruent to TD. Well, that's a property of the parallelogram. So I will say, yeah, maybe. It's kind of maybe, but yeah. So let's see this one, BE equal to ST. Okay, that's the first one. Now, BE equal to ST, right for that one. And then ES equal to TV. Well, this one is actually a must be. One of the main properties of the parallelogram is that opposite sides are congruent, not only parallel but congruent to each other. Without them being congruent, they wouldn't be parallel. So this one for sure is a property, like it's a necessary property. Now let's see. ES equal to BT, and we have it. And then, oops, and then, okay, BE equal to TS, parallel to TS. So parallel. Now, this is the tricky thing. If we have this, trying to do an isosceles trapezoid here. Yeah, we can say this one is parallel to this one, This is B, E, S, T. And then this one is this one to this one. But it's not a parallelogram, it's an isosceles trapezoid. So this is not sufficient to prove that this is a parallelogram. Because also like the difference between this and the other one is that it is involving two different things. Well, this is like things that are specific for the for the parallelogram definition, parallelogram properties. This one is basically, solution D is just this 100% right because that's the main property of a parallelogram, that the opposite side is parallel. So yeah, basically that. Remember, you can ask me like anytime you have a specific question. So just go to the Discord channel. Now let's see 24. So in the diagram below, lines L and M intersect lines N and P to create a shaded quadrilateral as shown. Which congruency statement will be sufficient to prove the quadrilateral is a parallelogram? So let's see this. So this is 1 and 6, 1 and 6, and 9 and 14. Actually, this is not even near. First of all, we're only using one angle from inside, and we're not using any of the properties of the, alternate or correspondence or consecutive. We're using vertical angles. It has nothing to do with parallel lines. And with a parallelogram, the first thing we need to think is in parallel lines. So yeah, definitely not what we're looking for. So let's see the next. So 5 and 10. 5 and 10. Okay, I like this. And then 6 and 9. Oh yeah, that's the problem. With this one, we're only proving that this side is parallel to this side. Because this is the second line. Alternate interior property. Okay, trying to do my best. And then these are the two parallel lines. So we are only using these two parallel lines. We're not using these to be parallel with this. So kind of the problem right here. So not enough. Now we have now let's see C, so 5 and 7. Okay, 5 and 7. And then 10 and 15. Kind of the same as before, I think. Yeah. Right here, we're only proving the other sides to be parallel. So we have this parallel to this, and then we have this second line here. For corresponding angles, these two are equal. And then we have this equal line here, and for alternate angles, these are equal, but still using this side parallel and this side parallel. Not what we're looking for. So it must be D, but just to make sure, let's see. So 6 and 9. So 6 and 9, and then 9 and 11. Oops, yeah, 9 and 11. And I see something that I like here. So first of all, we have these two parallel and this secant, so we can prove these two are equal for equal for alternate here. So this one is parallel to this one. And then we have and then wait. Then we have these two parallel, these two parallel, and this is the secant. And by corresponding angles, we can prove that 9 and 11 is equal. So we're proving that the four lines are parallel. This is our answer. Now 25. In the item below, square catch. What a weird name. Diagonals AH and CS are intersect at C. Okay, which that means true. So this square, the square has almost all properties. So let's see. ACZ. So ACZ, this one. Um, ZCH. So sorry about that. I don't know what happened. So CCH. Okay, this. Um, the one is greater than the other. Wait, why? Because of the property of the square. In a square, the diagonals bisect the angle, and they bisect each other, and they are perpendicular, and they are equal to each other. So, like basically any property you can imagine happening in a square. So this whole thing is 90. Since this is a bisector, an angle bisector as well, this is 45. This one right here is 45 as well. So wait. Now let's see this one, ACZ, the one that we already have. is greater than ASC, ASC, again, no. The same thing happened. This whole thing is 90. This is by 17. So this 45. This 45. So yeah, they are equal. So that's what happened. Now we have AZC. So ACC, this one right here, equal to SHC. SHC. Uh, like just doesn't have any sense. As I said before, this is 45. And one of the properties of the square is that the diagonals are perpendicular bisectors, so they do not just bisect each other and make equal segments. They form 90 degrees, so all of these 90 degrees. So doesn't make sense at all. And let's see D. AZZ is the one that I have. AZ, see this one equals C, Z, CH. Wait. Oh, actually, I made a mistake here. Okay, I'm coming back. Now, let me explain why this is not true. This is that I labeled wrong. CH is this one. CH 45, as I explained before. Now, what happened before, like what happened in C that I didn't read, is that the angle is SHC. This is 90 degrees. And this is also 90 degrees because perpendicular bisector the diagonals. So yeah, these two are equal. It's just that I labeled the wrong angle. I hope someone's realized that. Thanks that I realized that. But yeah, that's basically it. It's just the properties, this is kinda weird. It's just that when you know the properties really well, it just comes to your mind randomly. There's no other ways to just memorize it. I'm sorry, but geometry is a lot of memorization and practice. So if you are kind of stuck with the properties, I recommend doing Excels or if you have access to them. I know that in at least most of the MDCPS, Miami Data School, Public Data School, they offer Excel for free for students. So, I use free online exercises. Well, let's continue. So 26 in the diagram below is also a trapezoid star, diagonal AS, MRT, intercept point O, and ST, oops, parallel to array. So that's what we have. With non-parallel, so they are telling us it's non-parallel as it has to be because then it's also a trapezoid. So which pair of triangles are not always similar? Okay, so first let's establish which angles are similar and which sides are similar. So is an isosceles trapezoid, this side equal to this side. Also, it says similar, not congruent. So yeah, more complicated. But let's get to it. We know this angle, base angles are equal to each other, so this one equal to this one, and then this one equal to this one. And since it is an isosceles triangle, the diagonals are equal to each other. And diagonal, and diagonal. Now let's see the triangles. So STO, STO, this, and ARO. Okay, let's see this. Now, here we have equal angle, equal angle. We have that the ratio between this side and this side is gonna be equal to the ratio between this side and this side. Why? Because by definition of the theorem, like of the isosceles triangle, let me use another color. This small portion, again another color. Wait, I want that you guys can see what I'm doing. So yeah, this part right here equals to this part right here, and this part right here is going to be equal to this part right here. And what happened with these two triangles is that by the vertical angle theorem, the angles are going to be equal. And the thing is that since these two sides are equal, when I divide this by this, it's going to be equal when I divide this by this. Because, for example, it could be 8 and this could be 4. So this is also 8 and this is also 4. So yeah, that's basically what happens. Um, similar triangles, just oops, I forgot to take wait, there is highlight only. Well, it just means since we're talking about similar triangle instead of congruency, it just means that they're similar to each other. So yeah, these are always similar. Let's look at the other. S-O-R. No, this triangle. Um, E-R-O. So A-R-O. Okay, now we get to it. Yeah, this is just like think that like you can actualize it. There is literally no way they could be similar. Yeah, for sure. There is a way like it's perfect moment in which they are similar, but there's just no way that they could be similar right now. So yeah, I think we found our answer. That's a pretty straightforward one. Wait, I found it. Yeah, now better. Yeah, pretty straightforward. Well, let's check out the others. S-A-R, S-A-R, oops, S-A-R, and then S ATS, ATS. No, they actually have an equals line, but they wait this angle. Wait, they have an equal sign, but that's not the line that is going. Because this one is on. Sincerely, after analyzing a bit, I'm not sure how to explain it. And actually, not sure about this exercise. I know this must be the answer because it's just like almost impossible that you know this for be equivalent like for be similar to this. It's just that the angle between them, like, it is possible. It is possible, but they say are not always. So since it is very rare, this must be you will need this angle to be equal to this one, which is not always true. Um, I just trying to think about it. I know this angle is equal to this one, and this angle is equal to as well, and therefore, like, and this one is to this one, and then this is equal to this, and this, like, I know how to prove the opposite ones, but I can only think a specific case in which this angle could be equal to this one, or this angle when they are more closer, like like this, but not right now. Um, it's not always. And in the other case, in which oops, we are looking at S-R-A, this one, and ATA, I just say like more likely that to happen. Um, I don't know. I sincerely don't know how to put always. That's my sincere. I'm sincere right now. I know by definition of parallel angle, like of okay. Okay, I could. Oh, never mind. I got it. I'm so sorry about this. Okay, we have these two triangles. I want to prove if they are similar, so I can prove that this side is equal to this side, and this side is equal to this side. Well, no, I can only prove that. Okay, I can prove that this side is equal to that side, and we have a side common, and also I can prove that this congruent to this is actually not part of the triangle. Well, just for the line in common and this angle, I can prove that they are similar. So we have a side and an angle. And then we have another side here that is equal. Another side here that is equal. So yeah, that's a way like to think about it. And then but yeah. And then for STR, this is just the easiest one to prove that they are similar. So STR, and wait, what is the other? T. Okay, this one. Okay, we have that these two angles are equal. We have that this side is equal to this side. We have that this angle is equal to this angle. We also can say that this angle is equal to this angle. Because of the isosceles triangle here and isosceles triangle here. Um, and yeah, like it's very very easy to prove that one. So yeah, answer is B. I'm sorry about all the yapping and all the confusion right now. It was a weird exercise. So let's see, select the boxes to identify if each statement is always, sometime, or negative. So a square has four right angles. Yeah, that's basically the definition of a square, four right angles for equal sides. A square has two pairs of parallel sides. Yeah, that's always true. Square has two pairs of parallel sides. A parallelogram has four congruent sides. And it could be, a rectangle is a parallelogram because it has the opposite side are parallel. That's the definition of a parallelogram. And a square, I mean, square. Square is a parallelogram because the opposite side are parallel. And that's the definition of a parallelogram. But that's only when it is a square. If it is a rectangle, if it is, like this, just the opposite sides are the four congruent sides. So it is a sometimes. A parallelogram has four right angles. It's just the same as the rectangle and square definition. It is a parallelogram because the opposite sides are parallel and it has a right angle, but it's just in that specific case. So sometimes a trapezoid has two congruent sides. You know, we just saw it, and it's also a trapezoid. This side congruent to this side, but it's just in the case of the isosceles trapezoid. So yeah, that's it. Because we can have a right trapezoid, which is like this. Um, there would not be congruent sides. So it is a sum. Now let's see 28. This is gonna be the last one for today. So what are the appropriate reasons for statement in step 2 and step 4? So let's see at the statement. Okay, this is the okay. Okay, what we are given is that JKLM is an isosceles trapezoid. Okay, and KL parallel and these two are equal. This is our given. Now, YJKL, so this is equal to MLK. This is by the definition of a trapezoid. Yeah, that's the definition of a trapezoid. Of an isosceles trapezoid, base angles are equal. So same side interior angle theorem. No, that doesn't make sense. Same side interior angle theorem. No, that doesn't make sense. Nothing to do. Isosceles trapezoid base angles theorem. Isosceles trapezoid base angle theorem. Yes, the base angles of trapezoid and isosceles trapezoid. Isosceles are equal. Now we have that. So what we have is this angle. We have this side and this side, and then we prove that JKL is equal to JKL because reflexive property is the same side. So as you can see, we have a side, an angle, and a side. Side, angle, side. So it's pretty straightforward. SAS, side, angle, side, congruence theorem. So our answer is B. Yeah, that was an easy one. Yeah, I'm just gonna do 29. I do have time for that one. So we need to prove that the opposite side of the parallelogram ruin. What we have is that it is a parallelogram. Yeah, that's all we have. So we can say these two are parallel because they're congruent. Yeah, they're parallel because they're parallelogram. Nice. Now we see that the reason is alternate interior angles are congruent. So let me see. Uh, let me see my options and let me see which one are alternate interior angles. So I have 2 and 4, 2 and 4. No, they are not alternate interior angles. They are in the same side of the secant line. So no, not even near. I see 2 and 3. Okay, 2 and 3, that seems right. And then 1 and 4. Yes, they are alternate interior angles. Let's make the other. Let's see the others. 1 and 2. Nope, red flag. And then we have 1 and 4, 2 and 3. Yes, alternate interior angles. So we are left with B and D. So let's see 6 now. Reason 6. Um, 1 measure of angle 1 plus measure of angle 2 equal measure of angle 4 plus measure of angle 3. And we have substitution or alternators angle congruent. Reason like D just doesn't make sense. Like we're just, here we have the 2 equal 3, the 2 equal 3. So we're just taking the value and putting the 3. So it just doesn't make any sense to say alternative angles as well. Also 2 and 3, like they are, but we are not proving that they are equal. We're just substituting the value from one to the other. So D just doesn't make any sense. Yeah, B is our answer. That's what we're looking for. We're going to continue next week. Yeah, we're not going to finish next week. Maybe the next one, the other one. I hope so. So see you guys later.